So solutions day 2. This is to remind you really quickly about solute, solvent, and solution. Remember, solute is what's being dissolved. Solvent is what's doing the dissolving. When you put the two together, you get a solution. Outside, we have what going on right now? A what? Fog, which is called what? What have we been doing? Solution, suspension, or colloid?
It's a colloid.
It's a colloid. Good. Yes. Woohoo! We learned something. Woohoo! The Tyndall effect. Awesome. It's so smoggy. Okay. So we're in your packet that we just did with molarity, with a Pogel packet. We learned about concentrated and dilute, I hope. Concentrated is where we have a lot more solute dissolved. And dilute is where we don't have as much solute dissolved. Now, had I been able to show you the FET that's up on the blog, since the internet's down, I can't do that. You can actually see what happens when you add more solute to the solvent. But there comes a point at which you can't add any more and it starts falling out. It's sort of like my kids and the sugar in the Kool-Aid. There's only so much sugar you can add to water and it will dissolve, right? And then it falls out. And we called that fallout what? Who remembers what that fallout's called? Starts with a P. Precipitate. Precipitate. Okay? Now, that can happen when we do a reaction, or that can happen when I just put too much stuff in. Every chemical has a certain solubility. After that point, when it's reached a point where it's saturated, it can't take any more, okay, then it falls out as a precipitate. So up until that point where it's saturated, it is unsaturated. Okay? So, solute, solvent, here's my kids with their Kool-Aid, right? And we get a solution. Now, usually we do concentration solute over solvent. But what did we do in the the molarity packet? What was it actually? It was what? It wasn't that. It was moles of solute over liters of solution. So we had a little bit different. This is what molarity is. So this is the first one on D that you need to make sure you have a definition down at the bottom of D. Molarity is moles of solute over liters of solution. Okay, this is a little bit different, yeah. Okay, so if we got this definition, and it is a capital M. We use so many M's, it's unreal. But this is a capital M. Small m is meters. You have to do MOL to get moles, and then you have to write molecule out to get molecules. I know, this is my pet peeve. Yep. Okay, so what we're going to do before we write any more stuff down is we're going to just sort of walk through some problems with our head. Okay, so here we have, I need to make a solution. This glassware right here is called a volumetric flask, and when I make up solutions, I use a volumetric flask. It has one line on it. Unlike a graduate cylinder, it has many. It just usually has one line, and that one line is somewhere up in this area right here. Okay? You don't notice the green, or up in the red area. Since it's being really slow, it just finally came back on. The green here is what I weighed out. What I would usually do when I'm making a molar solution is I would put just a little bit of distilled water down on the bottom. I would put my solid in, swirl it around because it's easier to get it mixed in when I can swirl it really easily. Then I would put water in till the bottom of the meniscus, and remember, as we're looking at a line, the meniscus goes like this. Bottom meniscus hits that one line. So as it gets up closer, I get down to where I'm using just a dropper to get it right to where it needs to be. So to make this, I need to be able to know how much to weigh out, and I would use a 250 milliliter volumetric flask, like it says right here on the bottom, to make that. So we've got to figure out how much we need to make. We've got, or what concentration we're making. We've got 5 grams that were weighed out, and we're going to put in 250 milliliters, and I need to know what concentration that is. So this right here is a dot. It basically says it's a hydrate, meaning it's already got waters attached to it, but it's not really part of the compound. Okay, so I can knock them off. But I still have to include it. So I'm going to take a nickel, 2 chlorines, 12 hydrogens, and 6 oxygens, add it up and get this mass. Take the 5 divided by that mass, and I've got moles didn't finish. Okay, and we'll decide when to finish writing what I just wrote in just a second. There we go. Okay, the second step is to calculate the molarity. I need to get this into liters, the 250, so I divide it by 1,000 and I get 0.250 liters. And that's going to be what I divide the moles by. And this right here is molarity, capital M. And you do have to do the little spiky ends, not a curved M at the top. Another way, whoa, come back. Another way we can write it is with the brackets. Anytime you see brackets around a chemical, that denotes or means molarity. Okay, that means molarity. So let's look at this next one. What is the mass of oxalic acid required to, so we're just walking through a few of them, and then we're going to do some. Of oxalic acid is required to make 250 milliliters of 0.05 molar solution. So I'm going to work a little bit backwards. I'm going to take my molarity is equal to moles divided by volume, and I'm going to times molarity times the volume to get moles. And then for moles, I can get grams. Okay, so I can rearrange that equation. Change the milliliters to liters, divide by 1,000. Then we just plug it in, plug and chug. We get moles. Now we've got moles, we're going to have to add up the mass of this and take and times it by the moles. It's thinking about it. There we go. So we're going to take the moles, times it by the mass of oxalic acid, and we get 1.13 grams. And that's what I would need to weigh out to make that solution. All right? Okay, let's talk this one through. I'm not going to walk it through. I'm not going to write it here unless we need to have it written. So how many grams of sodium hydroxide are required to prepare 400 milliliters of 3 molar NaOH? So what's the first thing I need to do? Divide the milliliters by 1,000. So I get 0.4, right? Okay, now what do? I've got 0.4 liters and I got molarity. Yes. Okay, 0.4 times the 3. And what's that going to get me? Moles. So I times those two together and I get 1.2, right? Because 4 times 3 is 12, but I'm 1 away with the decimal. So it's 1.2. Okay, now I've got 1.2 moles. What's my next step? Okay, tell me again. So I'm going to add sodium, which is about 23, and I'm going to add oxygen, which is about 16. I'm going to add hydrogen, which is 1, and that adds up to about 40. So now I've got 1.2 and I've got this 40. What am I going to do with them? Times them. Times them together. So it's going to be bigger than 40, right? Because 1.2 is bigger than 1, but not much bigger. And when I have a multiple choice question like this, if I can do this in my head, I can go, okay, which one isn't it? Well, it's not 12 because it's not below 40. It's not 300 because 1.2 times 40 is not 300. So it has to be 48. Does that make sense? So you can really quickly narrow it down to the one that it is. All right? So let's do the ones that it didn't light up the right one. It was supposed to light up that. So we're going to talk about really quick before we do the problems, how you're supposed to make it. And I did that once. Does anyone remember what steps you need to add? How did I do it? I told you how to make it. So I have my volumetric flask. What's the first thing I need to do with my volumetric flask? Just a little bit of distilled water in the bottom. I probably rinse it out a couple times with distilled water because I don't know what was in it before. But I put a little bit of distilled water. Then I go weigh my solid, whatever I need out. Then I put it in the volumetric flask and swirl it and see what I can get to dissolve. And I keep adding a little bit more water and keep trying to dissolve it until it finally all dissolves. Then I'm going to fill it up to that mark, right, with distilled water. If I took 250 milliliters and then put the solid in, I would have this much left over water-wise. And then I would have a more dilute solution than what I needed. So we always add the water after we add the solid. Okay? All right. Going forward, maybe. Watch, I went too far. Yep. Okay, so this is the first problem that you've got on your notes. So let's go through this and walk it through. So what is the molarity when, here's something I need, 3.18 or 3.81 moles of NaOH pellets are mixed in a container of, and here's my volume of water. So what is molarity? Moles divided by liters. So I've got moles, I've got liters. That's pretty easy. 3.81 moles divided by 1.56 liters. What do I get? 2.44 capital M, and I also put the NaOH on it. That's part of the units. Okay, so that was pretty easy. That was pretty straightforward. You got the moles, you got the liters, just divide them. When you do your worksheet, I want you to show me the setup. Don't just plug in the calculator. Show me the setup and give me the answer. Okay, so let's go to the next one. What is the molarity of a solution that has, oh, this time I'm starting with grams of calcium chloride, and I've got milliliters. So I've got to do a couple things before I divide it, right? What's the first thing I need to do? Grams to moles. So I'm going to take calcium, which is 40.078. I think somebody double check me because I'm just doing it off my head. My 8 doesn't want to come out. There we go. And I've got 2 chlorines at 35.453. I'm going to add those up. What do I get? .110 something. 97. Okay, so then I'm going to take and 98. All right. So I take my 35.6 grams of calcium chloride and I do a factor label or a dimensional analysis, whatever you want to call it. And on top I'm going to put 1 mole of calcium chloride. And on the bottom I'm going to put that 110.98 grams of calcium chloride. Grams of calcium chloride go out and we end up with moles. Somebody throw that through. It should be around 3 something or 2, high 2s. It's what? Okay. Give me one more. 1, because we've been carrying 3 sig figs, so I want to make sure we carry 3. Of course, this one won't have it. It'll have 2, but that's okay. So the next one thing I need to do, oh, that is moles, by the way. I should write that. CaCl2. Okay, then I'm going to take that 550 milliliters, and I've got to change it into liters. And that one's pretty easy. I'm going to put it over here. Actually, not 0 there, because that's only, and that's liters. I'm going to take and divide those two. Computer's a little bit slower. And when I get to a final answer here, what do I have? It's going to be point something. 583. Okay, and I always put a 0 before a decimal because otherwise, if I don't see your decimal, I at least know you're supposed to have a decimal there. Okay, it's always a good thing to do that. And then I'm going to put capital M, and it's CaCl2. And that would be my answer. Okay, that's as far as we're going in notes today. We're going to hit molality next time because molarity and molality sound so much alike, but they're different. So we're going to just hit molarity. You have got the time now to work on your worksheet, to finish your POGL, whatever, and we'll come back together. The exit quiz has 5 questions on it, so we'll come back together at 15:02. Okay?